Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PLSQL developer just like you. This lesson is part of my series on effective management of PLSQL-based applications, and the focus of this lesson is using PLScope, a new feature in Oracle 11g for deep code analysis. Now, PLScope is a very powerful code analysis tool that was introduced in 11g. It's a compiler-driven tool that basically collects information about all the identifiers, the named elements of your code, variables, types, program names, and so on, and stores it in data dictionary views. And then you can, of course, access the data dictionary views, and one in particular, all identifiers, to get detailed information about your code. So you might say, well, what's different about that from all source? That's what I can do with all source. I can write queries against all source. I can look at the contents of my source code, for example. I can say, show me all the lines of code in my package name parse, or more specifically, show me all the lines of code in my all source data dictionary view for the parse package that contains the word string. So I can run that query. I can look at the results, and there's all the code that contains the word string in it. And of course, if I know regular expressions and want to do much more complex analysis, I can do that right from the all source data dictionary view. The problem with all source is that it's unformatted text. It's just free-form text. And it makes it hard to ask or get answers to more interesting questions like, where is a variable assigned a value? I can find all the places where the variable appears in my code, but how can I tell about how it's used and how it's connected to other things in my programs? And that's where PLSQL Scope really excels. So with PLScope, I can answer questions like, find all the locations in my program unit where a variable is assigned a value, where it might be modified. Give me a list of all the variables that are declared within my given program. Which programs call other programs down to the subprograms of a package, which is very difficult to do without all identifiers. Find the type of a variable from its declaration. It's one thing to say, find a list of all the lines of code that contain a string, but to understand more deeply how your program elements are being used, how and where a variable is being used, where is it declared, where is it referenced, where are my exceptions used in my programs? It takes a much different kind of analysis. And prior to 11g and the availability of PLScope, the only way you could really get answers to questions like this is with parsing. You would parse PLSQL code and analyze it. So products like Toad, which have their own PLSQL parsers, can give you some interesting feedback like this. But it's never been generally available before to a PLSQL developer. And that's what PLScope is giving to us for the first time. So we'll take a look at getting started with PLScope, then we'll look at simple examples and more complex examples. Then I'll introduce a helper package to assist you in getting up to speed and using PLScope. So first of all, PLScope must be enabled. It's off by default, and here's how you do it. Alter a session, or you can say alter for a given procedure. Set PLScope settings, and there's only one setting, identifiers : all or none, on or off, and it's off by default. If it's on, then when your program is compiled, information about every single identifier referenced in your program unit are written to the all identifiers view. And then, as usual, you query the contents of that view to get information about your code. You can also check the all PLSQL object settings to find out what your PLScope setting is. Let's take a look at that for just a moment. So here, for example, is a select distinct name, find all the program units from all PLSQL object settings for the current schema that have PLScope turned on. I run this query, and all these programs have PLScope turned on, which means that at the time the program was compiled, the session setting was set to identifiers all, and therefore that means that the information has been gathered for these programs. Now, the all identifiers data dictionary view contains lots and lots of information. In fact, let's just take a look at that for a moment. lots of columns, and we're going to take a look at a number of these through the examples, but the ones that are of most importance to us, besides the obvious things like the owner and the name, are the type. That tells us the type of identifier we're looking at. Is it a variable, a constant, a procedure, a package? Its usage. How is this identifier used in our code? Is it being declared? Is it being assigned a value? Is it a reference to that element? The line and column give us information about where in the line of code that identifier is found. The signature is a unique key. Let's take a look. So we've got the owner and the name and the type and the object name, the actual identifier name and type, but the signature gives us a unique value that we can use, and as you can see, it's a generated value by Oracle. We can use the signature to make sure that we're looking at the correct values or the correct identifiers. For example, I might have programs, multiple programs with the same name, overloaded programs. How do I distinguish easily between these different overloadings? You don't do it by name. You would simply check or connect by the signature. Usage ID and usage context ID are used essentially to reveal the hierarchy of identifiers in a program unit. The usage context is the parent for the usage ID. Usage IDs are not unique. They're actually declared or allocated sequentially in each different program unit. So the signature is the only unique identifier that we would be searching on or joining on. Usage ID is generally used with usage context ID, and I'll show you an example of that on the next page. So let's start with some simple examples. Let's simply show all the identifiers in the program unit, and that's in my PLScope all idents. But first, the PLScope demo setup will set up a number of programs that I'll be using in my demonstration. So let's run that first. And as you can see, there are a lot of different programs, a lot of different files in my demos that start with PLScope, and I'll be using most of them in this presentation. PLScope demo setup basically just creates a number of programs, PLScope demo package and PLScope demo 2. I'm going to enable PLScope data gathering when I compile these programs. So now when I run my queries against all identifiers, I should be able to see information about these two program units. Okay, so that's set up. Now let's take a look at the all idents file. So what I'm going to do here is select from all identifiers, and I'm going to join that with my source code so I can actually look at the source code for the lines that I find. And I'm going to find, let's see, order by, so I'm going to look for all the programs whose object name is demo, PLScope demo, and the owner is user. So I'm going to look at all their identifiers. And the rest of this is just a case statement that gives some order to the data that's being found. So everything that's in a package comes before the stuff in the package body. And then within a package or a package body, I'll order by package. Any of my types will go up front, and then my procedures and functions, and then my formal parameters after that. Let's take a look. Run my query, and I get this information. So PLScope demo, notice I have my package elements first, then my package bodies go away, then my package body elements. So the first element in my package is the package definition itself. I'm declaring the package, and there's the text associated with it. Then the next element that I've got is a global variable, and it actually includes a reference to number, which is an identifier in the PL/SQL standard package. So I've got a reference to the number data type. As you can see, this information is extremely detailed. Then I've got my procedures. So here's my reference to my subtype integer inside my procedure parameter list, and it goes on and on. Declarations of my procedure, declarations of my parameters, which are formal in or formal out or formal in out. That's the type for a parameter. And then declarations of my variable. And again, going back to my package, there are all the elements. I just have these two elements in my package spec. I have my two different parameters. And all of those references turn into lots of lines of data inside my all identifiers view. And then again into my package body, which has a lot more of the same, including local variables. So here's a local variable. Let's see, my local variable is declared right here. Another local variable, type is variable, usage is declaration. Then I have a reference to a variable. So notice I'm referencing L local variable here, and it shows up as a reference. Here's an assignment, in which I'm assigning a value essentially to the bad data exception. So there's an example of simply dumping out the data from the all identifiers view. Now remember, I joined to user source, so this text, the source code itself, is not a part of all identifiers. It simply has the line number, and then I would join to user source to get the actual source code. Otherwise it would just be showing me the types of references that occurred in my code. All right, let's take a look at more interesting questions. Show all the variables declared in a subprogram not at the package level. So I don't want to look at global variables, I want to look at local variables. Show variable declares. So I go to all identifiers view, look for my across all package bodies. Package specs can't contain any variable declarations, and I'll look for everything of type variable and declaration. And to avoid having package level variables, I'm going to use usage context ID greater than 1. Let's not include this line first. Let's run the query. And let's see, let's take a look at, let's order by usage context ID. Now you can see there are lots of things in here. In fact, let's also trim down what we're looking at to simply iname equals PL scope demo. There's just too much information there. Do this again. Let's try that one more time. Object name. No, it should be the name. User PL scope demo. Why is it not finding anything? Ah, silly me. I'm not looking at the name column. That's the name of the identifier. I'm looking at the object name, the program that contains the identifiers. So I'm going to run my query again, and now I see two variables. My two local variables. And notice my context ID is 2. Now let's see, did I not have any global variable levels here? I thought I had declared something at the global level. No. So let's actually modify PL scope demo, and let's declare a private global number. I'm going to recompile these programs. Let's run it again. And now I see 3 rows of information. Notice I've got my global and my locals, but I want this query to only show me locals. And notice my context ID. The context is set to 1 at the package level. If the context ID is greater than 1, that means it's a sub-element in the package, so it's inside a procedure or a function. So if I add this and, usage context ID greater than 1, then I'll just see those 2. So that's how I can restrict it to local variables. Show all variables declared in the package specification. Let's take a look at var, var declares. And let's look for a package specification. So change package body to package. Let's get rid of usage context. Run my query again, and here's my global variable in the package spec. And in fact, if I take off my object name restriction, I'll find all of my globally declared variables. And let's save that out to another file, PL scope gvar declares. This might be a very useful thing to run because a good best practice for packages is that you want to avoid declaring variables in the package specification and instead declare them in the package body only, and then give access to those variables through the package spec. So this would be a good way of identifying all those exposed package variables that you might want to change and move into your package bodies. Finally, and I think in a way most importantly, show the locations where a variable could be modified, var changes. So it's one thing to say find all the references to my variable by name. It's very much another thing to say find all the places in my code where this actually might be modified. That's a much harder thing to do, except with PL scope. So with PL scope, I'm going to again join all identifiers with all source. Let's skip all this stuff in sys. And I'm going to find all the lines of code in which my type is a variable, and I'm performing an assignment. That's it. Run my query. And here are lines of code that show me all the places where my code might be modified. Notice I'm assigning a value to my variable, assigning a value to a variable, and sometimes even if I'm simply making a program call that has an out argument, it'll show up here as well. So this is a really powerful way to immediately drill down and zoom on those parts of my code where a variable might be changed. So for example, I run my program doing some testing and my variable is set to null. I don't know why. How could this be happening? Well, I can use my debugger and step through my code line by line, and that's certainly a good thing to do. I can also run my analysis with PL scope and say, aha, it can only be modified in these three places. Let's take a closer look at those parts of my code. And so far as I know, PL scope is the only way that you can get at this kind of information from your Oracle environment. So it's a very, very powerful form of analysis. So there are a couple of different examples that are relatively straightforward in terms of their usages of the PL scope view. Let's take a look at some more advanced examples. Let's find all the exceptions that are defined in my code but never raised. Let's take a look at how we can reveal the hierarchy of identifiers in a program unit and how we can validate naming conventions with PL scope. So first of all, PL scope unused exceptions. Now first of all, I'm going to take advantage of the Whiff Clause, which is a new feature I believe added in Oracle 10G. I can basically create a little virtual table that I can reference below. And in fact, I've got two of them. So subprograms with exceptions, find all the programs using all identifiers that declare an exception. So I've declared my own user-defined exception. And then I've got subprograms with raise and handle in which I reference my exceptions. And I want to find out all the subprograms that declare an exception that don't raise or handle that exception. And I run my query. And I can see that if I take a look at PL scope demo, I declare ebad data, but I don't actually use it. Let's take a look. PL scope demo proc has two declared exceptions, user-defined exceptions, bad data and bad data 2. And notice, I raise bad data 2, I handle bad data 2, but I never do anything with ebad data. So either that means that I forgot to trap an exception that's going to be raised, or this is an unnecessary declaration. It's finding some unnecessary code for me. Again, find all the declarations of the exception and minus from them all the usages or references to the exception. If I never refer to it, then I never used it. The declaration has some sort of problem associated with it. So it's a more complicated example because I've got a minus in a couple of different subqueries. But beyond that, it's still not very difficult to do this kind of analysis. Wow, that's not much work for a lot of really good information. Let's take a look at the PL scope hierarchy script. Whoops. Let's do that again. Now what I want to do here is take advantage of the usage context ID. So there's a usage ID value that's assigned to each row, each identifier in the table. And if we take a look simply at all identifiers, let's go back to viewing all the identifiers. Notice I've got my usages of all my different identifiers, and I have, whoops, I didn't add the usage ID. Let's add that in. So the I usage ID and the I usage context ID. Run it again. So here's my usage ID, and they're declared essentially, they're allocated sequentially. And then I've got my context ID, and basically you can see that it points back to the parent. So the PL scope demo package declaration is the parent. Nothing higher than that. My procedure is declared inside the package spec, so that points back to, or its parent is the package itself, as is the global declaration. And then from there it goes down into successive levels of context ID. So that's the child, this is the parent. And we can actually expose that through a standard connect by start with hierarchical query. I'm going to start with any context IDs of 0. I'm going to connect my prior usage to its usage context ID. I generate a pseudo column called level, which is a part of the connect by start with syntax, and I'm simply going to pad on the left by the level to expose the underlying structure. I run this query, and I see the following. So my PLScope demo package has within it a variable and a procedure. The variable has within it a reference to the number data type. The procedure has within it references to its parameters. It has one in parameter. It has a second in parameter. And again, it just drills down from there. And my package body, whoop, that's just the package. No, that's the package body. Okay. And then it has the individual elements defined within it. So here's my exceptions, the assignment, the declaration, the assignment, in the pragma exception init, its declaration, and its references, its usages. So the usage of the context ID gives us an ability to understand the structure of these identifiers inside our code and where to find them. And finally, let's take a look at validating naming conventions. A lot of us have documents that contain naming conventions in them. For example, all of my parameters should start with p underscore, or all of my parameters should end with underscore in or underscore in out, and so on. And for the first time, you can actually validate those naming conventions right inside your code simply by using PLScope. So here what I want to do is validate the following conventions. Any in parameter should end with in, underscore in, any out parameter with underscore out, any in out parameter with underscore IO. So find all the identifiers in the PLScope demo package specification. Look for the identifiers whose type is a parameter, formal in out, or formal out. And look for the declarations of those parameters, not where they might be referenced, but where they're actually declared. And then I'm going to check for the following conventions. If the parameter type is formal in, then I want to look for all those declarations where the name is not like underscore in. And for formal out, underscore out, in out, IO. I run my query. And I find the following. That the param2 parameter of my procedure does not follow my naming conventions. Now let's go back and look at that package. And here we go. Parameter 1 underscore in, that's good. That follows the naming convention. Param2 does not follow the naming convention. So I've identified a violation of my naming conventions. Now as far as I know, none of the IDEs that you can get out there, Toad, SQL Navigator, PL/SQL Developer, SQL Developer, can yet provide this kind of analysis and reporting on naming conventions. But you can do it yourself with PLScope, and it's not that difficult to do. Okay, now I've been spending a fair amount of time building these individual scripts and obviously showing you how to use them. I've also created a separate package called the helper package that makes it easier to mine the data in all identifiers, because clearly it can get quite complicated. So rather than you having to sit around and writing query after query after query, I've decided to create a single package that consolidates a lot of this information. And one of the things I've done is build a set of views to hide the complexity, and then provide a package that offers high-level subprograms to perform specific actions. Let's take a look. So here are a number of different packages that you might find useful. Find all the public subprograms in a package. Find all the private subprograms in a package. And here's a very interesting one that I'll show you how we're going to use. Find all the ends of the declarations in my package bodies. So basically what this code does is join all identifiers and all source to find the first line number on which the declarations of my procedures and functions in a package body begin. Anything above that is still the declaration section for variables and constants and types. I declare these three packages. And now it's very easy for me to say, well, just show me all the public subprograms. So if I just say, bring up that definition, here are all the public subprograms in my various procedures and functions and packages. And rather than writing those queries over and over again, I've got it defined in that one place. And then what I did was create a helper package that pretty much consolidates a lot of the examples I've shown you. So in the helper package, you can simply say, show me all the identifiers that match a certain usage type. My identifier should contain a certain string, a filter. And then I could say, well, show me everything that should start with. So for example, I could say my formal parameters should start with p underscore. They should end with underscore in, underscore out, etc. Show me all the exposed package data. These are variables that are declared in the package spec, but not in the package body. Show me all the changes made to a certain variable. Show me all the unused exceptions. So as you can see, a lot of these are things we've already covered. And I've simply defined all these things in advance to make it easier to utilize them. So let's declare this package, compile the package, and let's take a look at using it. So I'll create this package called Great Package with lots of stuff in it. And then I'm going to do my different analysis. So show me all the identifiers in this package. Show me all the changes that are made in Great Package to the vSalary variable. I think that all of my parameters, anything that's formal in out, formal out, should start with P underscore. So this is a different kind of naming convention. So they should start with that. Show me any that do not. And I should have everything ending with this should be should end with. Isn't that right? Let's see. So yes, I should say not should start with, but should end with. And what I'm going to look for are all the in-out parameters that do not end with underscore IO. So my parameter should start with P. Any parameter should start with P, but my in-outs should end with underscore IO. And then find all the exposed package data, variables declared in the package specification. Let's clear out what's currently in my buffer. Let's run the script. And first we find all the identifiers in my package, all the changes made to vSalary. So here are the locations of changes made to vSalary. Looks like there weren't any there. Okay. All the identifiers of type formal should start with P underscore. And I found a violation. Input parameter in does not start with P underscore. And anything of type in out should end with underscore IO. And there we have an example of one that doesn't end up with underscore IO. And here are my exposed package variables. So it's a lot of the same functionality that you saw already in different queries, but I've bundled them together into a single package to make it easier to both start using PLScope and also to build upon those examples and add your own. And of course the idea here is that rather than write lots of different queries, put them into a single package. It'll make it much easier for you to work with PLScope and for others to take advantage of it as well. Some conclusions. PLScope gives you a level of visibility into your code that was never before possible. I think it's a very exciting enhancement, not only because of the specifics of PLScope, the kind of questions you can now get answered about your code, but also the fact that the PL/SQL development team is now looking at exposing more of this internal structure, internal information to us as users of the language. And I've heard them talk about also exposing the parse tree. So when we compile the code, we can get out the parse tree and actually do our own analysis of the parsed elements of the code. That can be very interesting as well. Unfortunately, the all identifiers view, the structure of it, how to manipulate the contents of that view, is not very straightforward. And I think you'll agree with me that it would help a lot to have a lot of examples and a helper package to get you started, which is why I provided it to you. And hopefully in the future we'll see interfaces to PLScope and all these different kinds of views and queries built into our IDEs, so that from within Toad, rather than me writing queries, learning about PLScope, building my helper packages, I should be able to just click on some elements of the interface and it will do the analysis for me. So I'm looking forward to that. But in the meantime, there's a lot you can do simply by using the kinds of queries that I've provided with you here and building your own.